Last we covered was minimum longitudinal reinforcement. We were talking about how to design a beam, and I didn't tell you till now what type of beam are we designing. But let's go with, now we know AS minimum. ये हमें पता चला how much this is from IS code in the last lecture. Now AS maximum is given there. The area of reinforcement, the maximum area of reinforcement is also given there, and it's given in the next clause. This is maximum reinforcement, page 47. The maximum area of tension reinforcement shall not exceed 0.04 dB. This is it. इसी का B clause जो आपने minimum पढ़ा 47 पे maximum reinforcement, the maximum area of tension reinforcement shall not exceed 0.04 dB. Now here D is depth, overall depth of the beam. B is width of beam. So this means 0.04 means it's 0.4% of the, this is 0.4% of, what is B? Beam cross B? Area of the beam. This is the area of the beam. So it's of the area of beam, or the cross sectional area of beam. So it's 0.4% of the cross sectional area of the beam. So the maximum reinforcement, उसकी भी limit है, it should not exceed 0.4% of the cross sectional area of the beam. Now again, why do we require maximum reinforcement? What is the purpose of this maximum reinforcement, maximum area of reinforcement? Minimum I told you last time. Maximum का purpose क्या है? It becomes, there are two things. First of all, once we keep on increasing the area of reinforcement, it tends to become uneconomical. The section itself becomes uneconomical. Then the second thing that happens is that the section becomes too rigid, because there is a lot of steel and the rigidity is actually increasing throughout the section. So we ensure that it's neither too flexible nor too rigid. So although it might become ductile at the same time, but ductility also comes with rigidity in the section. More steel you have, then more rigid it is. Ductility is it can stretch out while going towards the failure, but rigidity is its rigid behavior. It's becoming more rigid if you keep on increasing the area of steel. So now we have a limit to the maximum amount of reinforcement in beam, as well as this is also for the slabs. Or we can say for the flexural sections. The next is, now how do you provide the reinforcement? And we have already discussed this, that we provide reinforcement as tension, then we provide it as compression. This is compression reinforcement, this is tension. Then I discussed that we provide stirrups as well. But you can also have side reinforcement at the same time. This is side reinforcement. Now, where do we provide side reinforcement in a section? These are at the sides, at the center, or just below and above the center. Now, why do we provide the side reinforcement? What will be the purpose of this? If your section is quite deep, what will happen to shear in the section? I told you last time, what happens to the shear? The shear forces are along the depth of the section are somewhat like this. They increase towards the center of the section. They are least at the top and the bottom of the section. Why are they least at the top and the bottom? Answer. The shear forces always are acting perpendicularly and they travel towards the supports. अगर ये beam है, the shear forces would travel like this. The forces are traveling like this. The maximum amount of forces are transferred through the center of the section. So the shear, which is actually the shearing between the two planes in the beam, that's maximum at the center of the section. So the shear plane, which is at the center of the section, has got the maximum shear forces. For beams getting deeper and deeper, you have more shear forces, more and more shear forces in such beams. Then you need to provide the side reinforcement, and this side reinforcement is actually preventing the shear failure at the center of the section. So the purpose of this side reinforcement is to prevent the shear failure in deep beams. Now in clause 26.5.1.3 in the same page, side face reinforcement is given where the depth of the web in a beam exceeds 750 mm. Side face reinforcement shall be provided along the two faces. The total area of such reinforcement shall not be less than 0.1% of the web area and shall be distributed equally on two faces at a spacing not exceeding 300 mm or web thickness whichever is less. So where the depth is increasing beyond 750 mm. So deep beam is a beam which has got depth greater than, in a normal beam the depth will not be this much. It will be around, it's 2 times 300 mm, it will be 600 mm. For a beam to be classified under a deep beam, it has to be great depth उसकी 750 से ऊपर होनी चाहिए. तो वहाँ पर आपको साइड फेस रिइंफोर्समेंट देनी है. तो दोनों फेसेस पे, along both faces. ये एक फेस है, ये दूसरा फेस है. These are the faces of the beam. You have to provide along both the faces. The total area of such reinforcement shall not be less than 0.1% of the web area. So this reinforcement area should not be less than 0.1%. This was 0.4%. You have tension reinforcement running as 0.4%. But side face reinforcement which you provide has to be at least or greater than 0.1% of the, this is in percentage. This is minimum. This is the maximum for the tension reinforcement. So the web area and shall be distributed equally on two faces at a spacing not less than 300. Now this 0.1% is 0.05% on the one face and 0.05% on the other face. So इस face पे 0.05 होगा of BD and this will be 0.05 of BD. This is in percentage. At a spacing not exceeding 300 mm or web thickness whichever is less. Now at spacing we provide a spacing between the two bars and that should be not exceeding 300. In spacing between the two bars is the side face reinforcement. If we are providing more than one bar, another bar as side face, the spacing between the center of the two should be less than or equal to 300 mm. This should be less than or equal to 300 mm. Now next we are talking about shear reinforcement. Now the shear reinforcement, which is the important one, now how do we provide the shear reinforcement in the beam? And we have discussed this. We provide it as stirrups. We provide it as stirrups. Now these stirrups are the rings in a beam. Now this stirrup is the shear reinforcement. Or its stirrup. Now what does code say about this? It says that the clause 26.5.1.5, same page, maximum spacing of shear reinforcement first. The maximum spacing of shear reinforcement measured along the axis of the member shall not exceed 0.75 d for vertical stirrups and d, small d, for inclined stirrups. So there is a spacing between the two stirrups. How is it that? This is beam, and then you will have beam. The transverse bar is running. There is another transverse bar here. Now, to connect these transverse bars, we have rings of styrene. One ring, then the other ring. Similarly, continue. Now these stirrups will have distance between them. These rings will have distance between them. And what does the code say? The distance, the spacing of stirrups is how much? 0.75 B. Is it minimum or maximum? Shall not exceed its maximum. So it's less than or equal to 0.75 D. What is D here? It's the effective depth. D is effective depth. और effective depth किसके बराबर था? Overall depth minus, right? Phi S of the stirrup minus half times phi of L, or you can say D, capital D, जो हमने last time designation लिखी. D minus D of S minus half times D of L. Phi of D, जो डाया है उसका बाहर से. Then now there is, in no case shall the spacing exceed, next page पे दिया हुआ, in no case shall the spacing exceed 300 mm. So there is another limit to this. Either this spacing S, let me call it S, the spacing between the stirrups will be either equal to 300 mm or 0.75 D. What maximum? Maximum will be the minimum of the maximum spacing between two stirrups will be the minimum of these two. अगर ये 0.75D, if it's coming greater than 300 mm, then you will take only 300 mm. Or otherwise, अगर ये 0.75D आ रहा है, say 200 mm, then you cannot take 300 mm. You have to take maximum will be 200 mm. It's the minimum of these two. The maximum spacing is the minimum of these two between the two rings. Now, or the stirrups. So, is this clear? Clear? Yes. दोनों के बीच में स्पेसिंग आपको कितनी मेंटेन करनी? Now, what is this based on? ये 300 mm डिस्टेंस मैक्सिमम क्यों रखते हैं? What do you think? 300 mm मैक्सिमम. हाँ जी, थोड़ा सा सोचो. You know, what is the width of a beam? 300 mm till 400 mm, minimum 200 mm, maximum around you go to 400 mm. What is the center position? 300 mm. So the width, this is around average, you take it as 300 mm. You replicate that same and keep the maximum spacing between the two stirrups as 300 mm. Why so? Because the forces that are transmitted, they will be, when there are two stirrups, how the forces, shear forces transmitted? I was just explaining to you. It goes till two supports, there is a load somewhere. At maximum it goes at an angle of 45 degree. It may go till minimum to 30 degree पे transmit होगा. 90 degree there is no shear force transmission. This is actually the load flowing towards the support. That's what is shear force. That's why if you have 10 kN here, what is the shear force diagram that you will get? It is 5 and 5, somewhat like this. So 5 goes there, 5 goes here. It's the load 10 kN. So 5 उधर जा रहा है, 5 इधर जा रहा है. Now for this whole portion of the beam, from here to here, and for this whole portion of the beam here to here, the maximum load is 5 kN. But that's transmitted along the depth of the section. And I told you maximum is transmitted at the center. But at the same time it's transmitted along the section. This is the section of the beam. This whole section, if this is the shear force diagram along the depth of the section, maximum being at the center. So along the whole width of the section at the center, the shear forces are being transferred. So along the whole width, thereby that means somewhere here at the center of this, the whole along its whole width, the shear forces are being transferred. Now that's being transferred then to the next ring. So when you have a proportional limit between the two faces, एक तो यहाँ से ट्रांसफर हो रहा है और दूसरे along the length. When you have proportional limit between the two stirrups, then it's getting transferred at an angle of, mostly at an angle of 45 degree. The shear forces are getting transferred at an angle of 45 degree. Now if you extend this beyond 300 mm, there will be a zone in between them which will not transfer at 45 degree then. So it will transfer at an angle even less than that. So it's not effective then. Then the shear reinforcement does not become effective. यहाँ पर क्या होगा? The load that's coming from here, even if it's transferred at 45 degrees, it will still reach from this point to this. Now, if these two are at a stretch, then it will not reach to the next one. The angle will be not the same, it will go on decreasing. We can keep on discussing this because this is a long topic. How the shear forces are actually transferred and how the shear stresses actually develop. Now, what is the maximum limit for shear forces or reinforcement? Maximum shear reinforcement. So it's given here. First, the minimum one. The minimum shear reinforcement in the form of stirrups shall not be provided such that minimum one first. It's AS minimum. To separate it from जो longitudinal हमने किया तो यहाँ पर SY लिखा है because this is shear reinforcement. It shall be greater than 0.4 by greater than or equal to 0.4 by 0.87 MY into BSV. Now SV is used for this spacing between. SV here is spacing between stirrups. B you know is the width of beam. FY you already know, its yield strength. Now here it will be the yield strength of the shear reinforcement, not of the longitudinal reinforcement, because we are talking about Fy is the characteristic strength of the stirrup reinforcement in Newton per mm square, which shall not be taken greater than 450 Newton per mm square. Then B you already know, so this is the minimum. Minimum will be when this is equal to this. Minimum आपको तब मिलेगा ASV minimum when this is equal to this. Greater than this, you are getting, it has to be greater than or equal to this. So the minimum is this much. Where the maximum shear stress calculated is less than half of the permissible value and members of minor structural importance such as lintels, this provision shall not be complied. So lintels are also beams, but there we do not provide the shear reinforcement because they are not deep beams there. Lintel beams are not provided as deep beams. Then now, how do you design shear reinforcement? It's given in page 72. Page 72. If you go directly first to the clause 40.3, minimum shear reinforcement. Minimum shear reinforcement we just discussed. What you provide. Where tau B is less than tau C, given in table 19, minimum shear reinforcement shall be provided in accordance with 26 point जो हमने अभी पढ़ा 26.5.1.6. Table 19 is given on the next page. Now there is a term given here, design shear strength of concrete. Now, there are shear is provided by three things. I told you this before. One, shear resistance is provided by किन चीजों से shear resistance मिलती है? एक कंक्रीट से, सेकेंड, हाँ जी मैंने ये बोला, स्टाइरप से, थर्ड बेंडम बार से, and even the tension reinforcement that you provide or the long reinforcement that may also offer some amount of shear resistance. तो पहली चीज इसमें खुद कंक्रीट है. The first thing is concrete itself. So that is given in this table 19. The design shear strength of concrete tau c. The maximum वो किस पे डिपेंड करेगा? वो आप ग्रेड कंक्रीट का वो आपको क्या बताता है? What does the grade of a concrete tell you? वो आपको बोलता है compressive strength, characteristic compressive strength, doesn't it? So what will FCK, if you know for a concrete, then you know its compressive strength. Shear strength of concrete itself will be based on its compressive strength. There will be a relationship between the two. There is always a relationship between the two. Compression is like this, and shear is along its different planes. Now, compression reinforcement, compression strength and shear strength के बीच में एक relationship है. So that's given in this table. जो उनके बीच में relationship है. So first it's dependent on the concrete grade. If you see this table, concrete grade M15 से लेकर M40 तक इसमें दिया हुआ है. So once it's increasing in grade, if you check tau c का value क्या हो रहा है along any line, any row अगर आप check करोगे 0.2 से पहले रो में 0.3 जा रहा है, 0.28 से 0.3 जा रहा है. तो लास्ट रो में भी अगर आप चेक करोगे 0.71 से 1.01 जा रहा है. So it's with increase in, what is this? This is increase in compression strength. What is happening? The shear strength is also increasing, है ना? तो shear strength की increase हो रही with increase in compressive strength. वो ये भी increase हो रही है with increase in compressive strength. Now this table is giving you that the design shear strength of concrete with the increase in the compressive strength, but it's also giving you with respect to, there is one more thing जो आप different rows वो क्या है? If you see the first column, पहला column क्या है? 100 AS by BD. What is that? What is AS by BD? I told you this last time. This is percentage of steel. This is percentage of steel. ES, percentage of steel. Which steel? PT लिखा मैंने last time. PT is percentage of tension steel. So AS here is, अगर आप नीचे नोट पढ़ोगे, AS is the area of the longitudinal tension reinforcement. So it's tension reinforcement, which continues at least one effective depth beyond the section being considered, except at support where the full area of tension reinforcement may be used, provided the detailing conforms to 26.2.3, 2 and 2.3. Now, जो हमने detailing पढ़ी वहाँ पर, as per that, this is the percentage of steel. Now, कहाँ से कहाँ तक percentage of steel carry हो रहा है? Minimum heat, the code writes 0.15. तो minimum जब हमने last time देखा, what was the minimum steel area? It was 0.15%. And maximum अभी हमने देखा, what was the maximum? 0.04 BD. wasn't it? So into 100 would be 4. I was wrong just now. 0.4 नहीं 0.4%. So its maximum would be 4% in a beam. तो इसने लिखा है 3 and above. So the maximum is 4%. Now this is the percentage variation of the longitudinal tension steel. उसके साथ साथ अगर आप देखोगे ऊपर से नीचे अगर M15 का कॉलम आप देखो क्या हो रहा है 0.2 से 0.71. So it's also increasing with the increase in the percentage of tension steel. What does that mean? Shear resistance is also dependent on the tension reinforcement. तो इस टेबल से दोनों चीजों का पता चल गया. कंक्रीट से कितना हो रहा है, डिजाइन shear strength कितनी अचीव हो रही है और टेंशन reinforcement से कितनी अचीव हो रही है. So you are getting an idea about how much is the design shear strength already achieved by two things, concrete and tension reinforcement. What is then left? Stirrups and bender bars. Bender bars हम slab में देते हैं, stirrups we provide beams. So in either of the two you only provide one, stirrup or bender bar. B में हम stirrup दे रहे हैं. So we forget about bender bars and a beam. Slab में हम stirrup नहीं देते हैं, bender bar देते हैं. So we forget about the stirrup there. अब ये कौन, it will depend upon. So you will always have a shear force. Shear force you know how to calculate for a beam. पता है ना how we calculate for a beam? बनाया है ना आपने, how to analyze. Shear force से आपको क्या पता चल जाएगा? Shear stress कितना उस बीम पे आ रहा है. अगर ये shear stress जो उस बीम पे आ रहा है, if it's greater than the design shear stress from concrete and tension reinforcement, जो कि इसमें दिया हुआ है tau c, ये table 19. So we call this as, if tau b, this is जितना उस पे shear stress आ रहा है, shear stress on beam on section. If this is greater than tau c, this is design shear stress of concrete. If it's greater than design shear stress of concrete, then what do you do? What do we do? What would this mean? Shear stress जो उस बीम पे आ रहा है वो ज़्यादा है किससे? जो concrete and tension reinforcement ले सकता है. Then we go for stirrups. तब जाके हम बीम में stirrups देते हैं. क्यों? क्योंकि ये पूरा नहीं ले पा रहा है, कंक्रीट और टेंशन रेनफोर्समेंट पूरा शेयर स्ट्रेस नहीं ले पा रहा है जो कि आ रहा है, तो बाकी कौन लेगा फिर? नाउ इफ दिस इज लेस, अगर उल्टा है, if tau b is less than tau c, you will say you do not require stirrup then. Stirrup not required. But we still provide minimum shear, जो हमने अभी लिखा है इससे पहले. We still provide this minimum shear. Why do we still provide the minimum shear reinforcement? You do not require it. Tau b is less than the design shear strength provided by concrete and tension reinforcement. Then why do we provide it there? जवाब दो, डरते क्यों? हम क्यों प्रोवाइड करते हैं इसको? Absolutely, he's right. It's confining the. अब ये चार बॉक्स अलग अलग हैं in the country. Now you are actually confining all the bars together, making them into a single bundle. You do not require the shear reinforcement, but we are still confining it. The process of doing this is known as confinement. You are actually tying them up together such that इसके अंदर एक core फिर अंदर बचता है. That core and the reinforcement they behave together. जब भी लोड आए वो इकट्ठे उसका मैकेनिज्म इकट्ठे बने, तो हम इसको बांध रहे हैं. The only purpose then is we are actually confining it. The major role of confinement is in the columns, but we still do it in the beams. So now if this is equal here, you are then simply providing the minimum. If this is less, still the minimum. But if it's more, tau v is greater than tau c. Now how much then do we provide? So that's given here in 40.4, 72 page. When tau p exceeds tau c, given in table 19, जो अभी tau c table 19 में दिया हुआ है, shear reinforcement shall be provided in any of the following forms: vertical stirrup, bent up bars along with stirrup, third, and inclined stirrup. So you may also provide inclined stirrups like this. This is the beam reinforcement. You can also provide the inclined stirrups. Where bent up bars are provided, their contribution towards shear reinforcement shall not be more than half of that of the total shear reinforcement. ये bent up bar की जब बात आएगी तो वहाँ पर हम करेंगे. So right now we are concerned about stirrup. Shear reinforcement shall be provided to carry a shear equal to Vu minus tau c dV. The now if tau b is greater than tau c, then what is tau b equal to? Vu into b into d, right? Or small d. If you take only the effective portion, the overall portion is not. क्यों tau b क्यों है b? Tau b is Vu is shear force. जो shear force इस पे act कर रहा है. U क्यों है इसमें? It could be only V is the shear force. U is it's after multiplying by the load factor. So it's the ultimate shear force. Shear stress is, this is shear stress. Stress is always equal to force by area. This is force, shear force by area. The effective area is BD. Overall area is B into capital D. So this is effective area. Now tau v will be equal to Bu into Bd. This has to be greater than tau c. When this is greater than tau c, then we provide the shear reinforcement from this equation to carry a shear equal to Bu minus tau c into Bd. So what he's doing the opposite thing. This is not V, this is Vu by V. So this is Vu is greater than tau c into Bd. So this is then Bu minus tau c into Bd will be what? It will give you some value which is greater than 0. A value which is greater than 0. What is it giving you? It's giving you Vs, the force taken by or to be taken by shear reinforcement. क्यों? क्योंकि आपका tau b which is vu by vd is greater than tau c. तो vs कितना होगा फिर? ग्रेटर वैल्यू कौन सा है? vu by vd माइनस tau c. तो आपको वो क्या देगा? It will give you the shear resistance, the shear force to be taken by shear reinforcement. वही होगा ना? So that's what he's saying here. The shear reinforcement shall be provided to carry a shear equal to Vu minus tau c into Vd. The strength of the shear reinforcement Vus shall be calculated as below. Now, how does he calculate this? Now, strength of shear reinforcement. How much should it take? It should take Vs, or you can see this is Vus. What the code says. It has to take Vus. कितना फोर्स इसको लेना है shear reinforcement को, जो बाकी बचता है. Tau v was greater than tau s. Tau we got Vus from Vu minus tau c into Vd. So this much is the extra shear force that the shear reinforcement has to take. जितना shear reinforcement को लेना है. बाकी किसने लिया? Tau c into Bd किसने लिया? कंक्रीट एंड टेंशन reinforcement ने. Vu क्या है? टोटल shear force जो उस पर एक्ट कर रहा है. तो अब जो ये बच रहा है ये किसको लेना है? shear reinforcement को, जो हम स्टायरअप से. अब जब हम स्टायरअप देंगे तो Vus will be equal to 0.87 as per code into Fy into ASV into D divided by SV. When the stirrup is vertical and when it's inclined, then it's 0.87 into Fy ASV into D by SV into sin alpha plus cos alpha. Now, this is your S. SV is the spacing between two. It's from the center of one bar to the center to center spacing. इसको हम कहते हैं. This is between the center of the two bars. SV. Then, what is D? D is the effective depth of the section here. Effective depth, and ASV is area of the shear reinforcement. Now what is known to us? जब हम वो पिछली फॉर्मूला अप्लाई करेंगे, Vus will be known to us. Vus will be equal to Vu minus tau c into Vd. So Vus is known to us. Depth will be already known to us because पहला स्टेप हमारा क्या था? ज्योमेट्री फिक्स करना. दूसरा स्टेप क्या था? उसमें टेंशन रेनफोर्समेंट डालना. तो तीसरा स्टेप ये आ रहा है. So we already know D now. Then SV is the spacing. We'll fix the spacing between the two bars. Maximum we'll fix it at 0.75 D or 300 mm. उससे कम भी हम कर सकते हैं. Then we'll get the area of the shear reinforcement. This is area of shear reinforcement that you will get of a single bar. What? If you see what is D by SV ratio there, ये अलग अलग मैं निकालूँ इसमें. VUS is proportional to D by SV. What is D by SV? What is it telling? SV by D or D by SV. ये रेशो आपको क्या दे रहा है? It can give you the geometrical angle at which the shear forces are. Shear forces are transmitting. Now if D becomes greater here, D becomes greater, what will happen is that VUS you already have, then your SV has to be proportionally also increase. It should also increase, but you cannot increase it beyond a limit, because then the forces will not be effectively transmitted.